Hello everyone. So in this media we are going to cover aspects of gear. Okay, all the gears, their construction, where it is used and everything. It's gonna be a very important topic and for your knowledge, and we must have studied in our during our BTech time, whether it is in mechanical field or in marine engineering field. So we'll see those aspects. I have tried to make it more concise with the diagram, so I have made it in crisp and clear content so that it becomes it's easy for you to assimilate. Okay, so we'll just go through the slides, that's it. Nothing is gonna be there because it is there are plenty of things which are self-explanatory. It's going to be little lengthy, but we'll try to cover all the aspect. If not, then we'll cover in a separate part of the video. Okay, so various drives that are used for transmitting rotary motion from one shaft to other shaft are different types of coupling. So we are using it coupling. So you must have seen whether it is steering motor or whether it is any of your pumps. So there are couplings. So these couplings are of different types like Muff coupling, flexible coupling, Flange coupling, Oldham's coupling, universal coupling. Now, what are the limitations of these couplings? So limitations of these, at the most driver speed can be transmitted to driven. Either overdrive or speed reduction are not possible. So in these type of coupling, so your speed reduction, because when we study this gear ratio and gear theory, there we can get the aspect of this speed reduction and all. So here which is not possible. Now when we speak about this, then we have belt and rope drives. So we have another aspect after coupling is that we have belt and rope drives, and then we have timing belt and chain drive, and then we have gear drives, which is the key aspect of discussion today. Now see, belt drives which is non-positive, belt drives which are positive. So this is the two schematic diagram, or you can say picture. We'll see what is positive and non-positive. So when we speak about positive drive, a drive which gives exact velocity ratio without fail and without any fluctuation. So if there is no means say reduction, or there is no there is the exact velocity ratio when it gives, so there we have what is known as positive drive. Sorry, when we speak about non-positive drive, so non-positive drive, a drive which does not give exact velocity ratio without fail and without any fluctuation. So this non-positive drive is not giving us this exact velocity ratio. Now slip and creep are main factor responsible for being non-positive. So why there are so losses, we are not getting the exact velocity ratio? The reason being is that there are two factors which contribute to the loss of drive. Okay, and that is slip and creep. Now timing belt driven positive, though they are positive drives, they cannot be used for very large powers and small distances. Okay, chain drive, so this is the chain drive that we were talking about. This is the sprocket that is driven, and then the pedal gear that is driver. You must have seen in your cycle also. Okay, in cycle this is available. Now this, here you see the diagram, this is pitch cylinder fraction discs. Now these are toothed gear. In early days, pitch cylinders were used to transmit power. Power transmitting capacity depends on friction. Not suitable for higher power transmissions, slip may occur. So if we have a higher power transmission, it is not suitable for that, and there are chances that there will be slip. In order to come out of these limitations and to transmit definite power, projections on discs known as teeth were provided. So now in order to provide the definite power, what we have done is that we gave projections which are known as teeth. They are known as toothed gear. They can be positive drives. So they are what is known as positive drives. So spur gears. So you can see these are the spur gear. So here you have the driver and then we have the driven. So driver is the A and the driven is the B. Okay. Gears are used in various machines. Now we'll see the examples now where clocks, energy meters, gear pumps, centrifuge, automatic vending machines, hoists, cranes, automobile gearbox, marine reduction gearbox, roll mill or machines, differential gearbox, floodgate, operating machines, coal pulverizer, and wire drawing machines. Okay, gears can be defined as a machine element used to transmit motion or power by means of progressive engagement of projections called teeth. Motions or power is transmitted from one to another when projections on one gear mesh with recesses on the other. So there is a meshing that occurs. You must have seen even in your turning gear. Turning gear, when we are engaging the turning gear to turn the engine before starting the main engine, we are turning it. So it's just nothing. We are engaging the gears so that it drives it. Okay. Now gears can be used either for motion transmission or power transmission. Now when we speak about motion transmission, see here you have the floodgates in dams operated by bevel gear. So this type of projection, this type of construction is nothing but it is of bevel gear. When we speak about power transmission is differential gearbox of a four-wheeler. So this is a differential gearbox of a four-wheeler. If you must have opened your car engine from the front in the bonnet, then you must have seen this type of construction. Okay. Now advantages and disadvantages of gear drive. So what are the advantages? Can transmit definite motion or power, positive drive, exact VR velocity ratio. Okay. Can transmit large powers which are beyond the scope of belt, rope and chain. Even in your purifier, in Mitsubishi purifier, you have what is known as horizontal shaft and vertical shaft. They are being driven by what is known as your gear mechanism. Okay, so there also, now here we have more compact drive construction, more reliable service, very high efficiency, can be used for extreme low speeds where other drives cannot be recommended. Now what are the disadvantages when we speak about it? Is manufacturing costly, high maintenance cost, manufacturing requires special tools and equipment, error in cutting teeth may cause noise and vibrations during operations. Now because over a period of time there will be a wear and tear, it will be worn out, the gears will be worn out, so that will cause vibration and there will be operational defects that will occur. Requires careful attention for lubrication and cleanliness. So we require what is known as careful attention for lubrication and cleanliness. Require precise alignment of the shaft. So shaft has to be precisely aligned so that it can transmit the power, because if there is any, we have to check the clearance also. Even after matching the gear teeth, we see how much is the clearance, whether the gear has to be changed or not. So these were the advantages. So now classifications of gear, when we classify the gears based on type of mesh. So we type of mesh, that is external gears, and then we have internal gears based on peripheral velocity of gears. Okay, these were on the based on the type of mesh. So we have externally and we have internally, and now we have peripheral velocity, low velocity gears up to peripheral velocity of 3 meter per second, and then medium velocity, so we have 3 to 15 meter per second, and we have high velocity gear wherein we have peripheral velocity of more than 15 meter per second. Now when we speak about based on the positive position of shaft axis, okay, three categories we had, and the third category we have is the classification of gears according to shaft axis. Then we have parallel shaft, we have intersecting shaft, we have non-parallel and non-intersecting shaft. Based on that, parallel shaft has got spur gears, helical gears and rack and pinion, whereas intersecting shaft has bevel gears, straight bevel gears and spiral bevel gears. Just now we have seen the picture, the bevel gears in the log gates for the dams. Now when we speak about non-parallel and non-intersecting shaft, we have spiral gears, worm and worm wheels. They are of non-parallel and non-interacting shaft. Now when we speak about spur gears, combination of two or more meshed gears used to change the rate of rotation, the direction of rotation and amount of torque used for parallel shaft. So they are used for two shafts which are parallelly. You can see here in the diagram as well, as per their motion. Now when we speak about spur gears, smaller pinion, larger wheel. So we have pinion which is smaller and we have wheel which is larger. So you can see in that diagram as well. These are the spur gears. You can see driven gear, and then we have driver gear. Gear for cement industry. So you can see here, this is the gear for the cement industry. Rack and pinion, used to convert rotational motion into linear motion or vice versa. So we have what is known as, this is the rack and this is the pinion. This is the rack, straight one, and this is the pinion. So we are converting what is rotational motion into linear motion. So this will be linearly try to move. So we are moving this wheel, and what is happening is that because of which this is trying to move wherever is the drive, whichever is made the driver. Okay, rack and pinion. So you see here rack and pinion, you must have seen in your drilling machine. Okay, so this we are making the drive, and so this rotational motion is turning into be the linear motion. So these are the examples of rack and pinion. You can see in the diagram. Now when we speak about helical gear, now when we are speaking about this Mitsubishi purifier, so there we have these helical gears used to connect parallel shafts. So now they are used to connect these two shafts which are parallel. Okay, and then we can also have advantages. Helical gears have better contact ratio as compared to spur gears. Now contact ratio is equal to number of pairs of teeth in mesh. So when they are in contact, how many teeth are there which are in contact? That is known as contact ratio. So two terms which is very important when we are discussing gear. One is the contact ratio and other one is the VR that we discussed in the beginning. If more teeth are in mesh, load of transmission is shared by them. So if more teeth are there, so the load of transmission will come on the more number of teeth as compared to if the load of transmission coming on 3 teeth, then it will have lesser impact on the gear, and or whether when it is in the other hand when it is coming on 2 teeth only. This results in smoother and noise free vibration, free power transmission. They are more efficient. Now what is that disadvantage? An axial pull or axial thrust in the direction of helix is induced onto the bearings holding the shaft on which these gears are mounted. So there is an axial thrust which is there, which is not good for it. So we can see it here over here. Gearbox for coal pulverizer. Okay, hobbing a single helical gear, northern tool gear. The hob is situated above the operator's left hand. So you can see here operator's left hand hob is situated. Now industrial gearbox, the oil spray head is located just to right of the nearest pinion. Okay, you can see these diagrams. Now we have gear transmission. How it is happening. Now you see here, this is the input shaft. So here you have the input pinion. Okay, and then we have 2-stage parallel shaft helical gear set from the skill electric drill. So here you have 2 set of, see here you have 2 set of shaft. One is this one and the other one is this one. Now this is the output shaft here, and then here you have what is known as ball bearing, and then here you have bushing, always all together. So this is a, you can see the cross section view of it. Now herringbone or double helical gears. When we speak about this herringbone or double helical gear, herringbone gears are used to connect 2 parallel shafts. So they are used to connect 2 parallel shaft. A double helical high speed gears on a 5.5 meter hobbing machine. See, double helical gear, it is a double helical gear, it is a hobbing machine. Now hobbing a double helical gear. Advantages: since they are formed by 2 helical gears opposite hand on the same shaft, the axial thrust on one is nullified or counterbalanced by equal amount of axial thrust on the other side. This results in greater power transmitting capacity, ensures noise free transmission, smoother transmission, vibration free transmission, induce even load on the bearings, high efficiency. Okay, so these are the advantages of them. Now you see here, these are the bevel gears that we were speaking about. You can see the chuck bevel gear mechanism. Okay, now we'll discuss bevel gears used for intersecting shafts. Most transmission occurs at right angle, but shaft angle can be any value, but the shaft angle can be any value. Okay, spiral bevel gears, so they were also of two types. So this one is the spiral bevel gears. Now spiral bevel gears, and then we have straight bevel gears. Teeth are straight, shaft angle is equal to 90 degree. Now we have, when we speak about spiral bevel gear, teeth are curved, bevel pinion axis passes through the center of the bevel gear, shaft angle is 90 degree. Hypoid bevel gear, this is another one extra type. Teeth are curved, bevel pinion axis is offset to the center of the bevel gear, so they are little offset as compared to the another one. Now straight bevel gears or spiral bevel gears as well are used for the shaft angle of 90 degree. If bevel pinion axis passes through the center of the bevel gear, they are known as spiral bevel gears. If bevel pinion axis does not pass through the center of the bevel gears, they are known as hypoid bevel gears. So this is the difference between the spiral bevel gears or hypoid bevel gears. Advantages of spiral bevel over straight bevel. Because of spiral angle, contact ratio CR, number of pairs of teeth in mesh is enhanced, resulting in smoother and efficient transmission. So one thing we should remember is that whenever this contact ratio is increasing, load sharing is increasing, and your power transmission becomes smoother and efficient transmission is there with lesser vibration. So contact ratio, you know, number of pairs of teeth in mesh. You see the bevel gear, wide drawing bench. So these are the bevel gears. Spiral gears or crossed helical gears, that is also known as skew gears. Now they are used to connect two non-parallel, non-intersecting shafts, skew shafts. Now when mounted on non-parallel shaft, they are crossed helical gears and usually have the same hand. So you can see here from here, spiral or crossed helical gears. Now what we have is something which is known as worm gear. You can see here worm gears. These are the motors, electrical system, you will find it more. Worm gears used to change speed and direction of rotation. So they are used to change the speed and direction of rotation, used for connecting skew, usually 90 degree. So they are usually connected to 90 degree. High gear ratio, high load capacity. So they have a higher load capacity and they also have high load. Type of worm gear, they are non-throated or non-enveloped surface contact, single-throated or single-enveloped line contact, and then we have double-throated or double-enveloped point contact. So you can see here input shaft and bearing housing. Okay, rolling element bearing, then we have output shaft, third stage angle, second stage wheel, pinion, first stage oil groove, and all these things are there. You can see the rotations as well. Then we have a hob cutter for generating gear teeth. So we have this is a cutter which is used for generating gear teeth. Now when we speak about this gear ratio is equal to number of driver teeth upon number of driven teeth. So gear ratio is, so now the third term which is very important and significant to know is that gear ratio, number of driver teeth, number of driven teeth, that is gear ratio. Gear ratio is also called mechanical advantage. So how much mechanical advantage we have, that is nothing but it is the gear ratio, number of driver teeth upon number of driven teeth. Types of gears: spur gears, worm gear, rack and pinion, bevel gears. Now a selection of small gears. We have spur, sorry, the spur gear that we discussed, and then rack and pinion, herringbone, hypoid, worm, and then bevel. So in one page you can see all this. In spur, helical and herringbone, gear action is equal to one cylinder rolling on the other. So one cylinder is rolling on the other. In rack and pinion we have what is known as line contact. So here we have gear action is equal to one cylinder rolling on rectangular block. Here we have gear action is equal to one frustrum of cone rolling on the other frustrum of cone. So they are the frustrum of cone which is rolling one on the other. So this type of mechanism you must have seen in your fire pump, this one what you call is a priming unit. So if you remember, so this is nothing, one frustum of cone rolling on the other frustum of cone. Now gear terminology. So this is known as something what is known as your face width. This is the flank, this is the tip, this is the addendum, this is the addendum, this is the dedendum, this is the root fillet, this is the circular pitch that we are discussing about, this is the dedendum. So addendum, and then we have dedendum. So addendum denoted by A, dedendum denoted by B, we have root fillet, we have tip, and we have the flank, and then what we have noticed known as the face width, and then addendum circle, and then we have dedendum circle. Okay, and then we also have circular pitch, and then we have root fillet. Okay, so this is the same thing that we discussed: flank, bottom land, pitch. Okay, spur gearing, mesh, all the thing you can see here: top land, face width, tooth thickness, what is known as addendum, the upper circle. Okay, and then what is known as is the lower circle, is that there you have the perpendicular that is drawn here from the flank to the flank. There you have, from that distance is known as dedendum. This is your working depth. Okay, this is your working depth. Okay, from the clearance circle. So this is the clearance circle, and this is the total depth. Okay, this is dedendum circle to the dedendum circle to the addendum circle. So that is known as your total depth. So please remember this working depth and total depth, addendum, dedendum. So this is the clearance between this working depth and total depth. Okay, so that is the basically your clearance. So bottom land you seen, and fillet radius was as well. You can watch here from this diagram as well. Same thing is being explained over here. So you can see gear rotating and in what sequence, and how much is the contact ratio. Now we'll discuss something about what is known as backlash. Okay, so you can see the gear when they are rotating, through the graph it is being depicted. Line of action, pressure angle. So line of action, line tangent to both base circle. Okay, so maybe this video will become lengthy, so what we'll do is we'll stop here for your reference. So from in the next part we'll discuss from the backlash and to till the gear terminologies, what are there and what are different aspects are there, we'll discuss in the next part of the video. So in this media we had already covered all the types of gear, how many types are there, what are their advantages, what is the contact ratio, velocity ratio. Okay, each aspect, the types of gear, where they are used, their advantages, disadvantages, everything we have covered. Okay, thank you so much.